Welcome to the Bcm Class, Basic Civil and Mechanical Engineering. So today is our lecture, fourth lecture. In last class, we will see about the refrigeration. So in this refrigeration topic, we will discuss about vapor compression refrigeration system and then vapor absorption refrigeration system. In that we found the only difference between these vapor compression and vapor absorption system is it have compressor. In vapor compression system, in vapor absorption system, compressor is replaced by three components. First one is absorber, then pump, then generator. Okay. So today we will discuss about types of air conditioners. So before going to that topic, we have to understood some basic terms related to the air conditioning system. So first term is dry air. So dry air is nothing but it is an atmospheric gas having the 79% of nitrogen and 21% of oxygen. Okay, and its molecular weight is 29. So this is dry air. Then what is moisture? So moisture is the mixture of dry air and then water vapor. So moisture is also air which is in a gaseous form. So in that air plus water vapor mixture. So this is known as the moisture. The quantity of water vapor present in this air will be depends upon the temperature. Okay. So for dry air, 0% only will be the water vapor present in this dry air. But in saturated water vapor, it will have 100% of water vapor. So in saturated water vapor, you have the 100%. 100% is nothing but it doesn't mean that that will be a completely a water vapor. Saturated means it will absorb the amount of water vapor fully. For example, let us take a space. So this is space. In this, we have the dry air. Okay, so in this we have dry air. Let us assume that it can be able to hold nearly a 4 particle of water vapor. It can be able to hold. Okay. Then if this section absorbs nearly 1% of one box will be covered with water vapor. Then what is the percentage of water vapor present in it is nothing but 1 by 4 into 100. That is 25%. Okay. If it is if the water will be filled in two boxes, means the one is replaced by 2, therefore it will become 50%. If 3 boxes means it will be 75%. If all the boxes means it will be 100% saturated. If we add one more box of water vapor, means it cannot hold it, simply reject it. So this is the meaning of saturation. The next we will see about the humidity ratio or specific humidity. Why here we have to see about these terms? Because throughout this air conditioning system, we have to continuously use these terms. So dry air, and then moist air, and then humidity ratio or specific humidity, and then relative humidity. Okay. So what is humidity ratio or specific humidity? So this is nothing but ratio of mass of water vapor to the mass of dry air. It can also be given as mass of water vapor present in per kg of dry air. Okay, this is the humidity ratio. So let us take a same space example. I take a space which having the 1 kg of dry air, 1 kg of dry air. Okay, so this is dry air particles. So in that, if I add 100 grams of water, then what is the humidity ratio? 0.1 kg of water vapor divided by 1 kg of water, sorry, kg of dry air, which will be equals to 0.1 humidity ratio. So this is known as the humidity ratio. The next we will talk about what is relative humidity. So in previous slide itself, we have to deal with the saturated state. Okay, saturated state is nothing but state at which dry air can absorb all the amount of water vapor which can able to absorb. Okay, so that is the saturated state. So red humidity is nothing but the ratio of actual mass of water vapor in given volume of mixture, actual mass of water vapor in a given volume of mixture divided by maximum mass of water vapor in same volume of mixture being saturated at same temperature and pressure. Okay, let us illustrate this one. Let us take the same example as a space. So I will take space which is at a saturated, and then I have to take another one space which will having the same temperature and pressure. T1, P1. This is considered state 1. This is considered state 2. T1, P1 which is equal to T2, comma P2. Okay, so this is at saturation. This is at normal state. Normal state. It cannot be a saturated state. Sorry, it may be saturated state, or it may not be a saturated state. Let us consider this as normal state. So, in the in saturated state, I have a take this same 100 gram of water vapor. Okay, in saturated state, I have 100 grams of water vapor. So, if I add, can I able to add more than 100 gram of water vapor? No, we cannot possibly because it is already at a saturated state. So, in normal state, it will have a 50 gram. Normal state, we will have 50 gram. Now, what is the relative humidity? Actual mass of water vapor in given volume. Actual mass of water vapor in given volume is nothing but 50 gram. Then maximum mass of water vapor in same volume of mixture being saturated at same temperature and pressure. So this is nothing but 100 gram. what is 5? 5 is nothing but 1 divided by 2, that is 0.5. So one thing we can able to consider readability percentage always. If it is 100 percentage means it is the maximum. So if it is in case of 100 percentage means what will happen? So this will also at a 100 gram of water vapor. So one thing I forgot to tell that. So how the temperature and pressure will be same as T2 and T2. Volume also will be same D1 and then T2. So if it is a 0.1 meter cube means it will also be 0.1 meter cube. Okay, next we will move on to the refrigeration, so air conditioning systems. Normally, air conditioning systems is nothing but a type of refrigeration system which will provide the thermal comfort condition for the human beings. Okay? So that is the air conditioning system. So it can be classified into two categories. One is summer air conditioning system, and then another one is the winter air conditioning systems. So in summer air conditioning systems, needed for the place which will having the hot and dry condition. So hot and dry condition means we have to use the summer air conditioning system. If it is hot and humid means we have to use the winter air conditioning system. So this is a basic type. Okay. So we can classify the air conditioning system based on the requirement as well as based on the loads. So we have to see another classification in next lecture, but this is the basic classification. One is the summer air conditioning systems and another one is the winter air conditioning systems. Okay. So we will see one by one. First one is the summer air conditioning system. Summer air conditioning system. So in some summer air conditioning system, the outdoor condition, that means the environmental condition of your city or environmental condition of your country or environmental condition of your local location will be a 40 to 44 degrees Celsius dry bulb temperature. Dry bulb temperature is nothing but if you measure the temperature with a normal thermometer, okay, without cover the bulb with a wet cloth, then it will be known as the dry bulb temperature. You just understand this term because if you want to completely study with these things means you have to know about the psychrometry. So that is not our focus. So just understand diode temperature is nothing but a normal temperature machine. Okay, so that will be 40 to 44 degrees Celsius, and then relative humidity is a 20%. Okay. So if your outdoor conditioning will be at this range means you have to go for the summer air conditioning system. Because in all the air conditioning system, the indoor condition will be 25 degrees Celsius total temperature and 60% relative humidity. So this is the standard one which will give the thermal comfort condition for the human beings. Okay. So this is the hot and dry outdoor condition system. So next we will move on to the so this is the schematic of summer air conditioning system. So we will classify this category into we'll take this as a 0 to 1. This is nothing but entry. So this is the entry. And then 1 to 2 is filter. Then 2 to 3 is we have the cooling coil. Okay. The next we will having the humidifier. The we will having the next we will having the water regulator. And the next we will having the air to air conditioning space. We have to supply our air into the air conditioning space. Okay. So in the first step, filter, air will be entered into the filter just to filter the unwanted particles, dust like this, like that things. Okay. In next case, when it will be entered. So in this section, there is no change in temperature, but when it will be entered into the cooling coil. Okay, so this is the cooling coil. So in cooling coil, we have to supply an external refrigerant or external water, water that just cools the air. Okay. So here the temperature will be getting reduces. So here the temperature is getting reduces. The specific humidity omega value cannot be changed. Okay? Because we have to only play with the heat cooling. So this is known as the sensible cooling. Sensible cooling is nothing but whenever you start cooling process, its temperature decreases. So this is known as the sensible cooling. Okay. The next section will be the humidifier. So in humidifier, we have to circulate the water. We have to circulate the water through a pump. So this will be circulated through the pipette. So this is nothing but a spray-like arrangement. So the air will be passed between the spray-like arrangements so that we will be getting some water vapor in it. Okay. So due to that, what will happen? Its specific humidity outside, when it will be out, getting out, the specific humidity will be increases. Temperature will be decreases because some amount of cooling will be occurs in this place. The next it will be move on to the water eliminator. So some large size water particles carried by the air are retained by this water eliminator. Okay, so due to purification process, there is a some probability the air can carry the large size of water particles. So to eliminate this, we have to use the water eliminator. Then it will be enters into the air conditioning space. So this is the working structure of summer air conditioning system. Next, we will move on. So this is the complete diagram. So in this slide, I have to split this one, and in this slide, I have to completely given this diagram only. So this will be important for your examination. The next, we will move on to the winter air conditioning system. So in winter air conditioning system, the variable temperature value will be 10 degrees Celsius. So it will be a very cold day. And then relative humidity will be 80 percentage. Relative humidity very high, and then 10 degrees Celsius temperature it will be very cold. So our thermal comfort condition is once again 25 degrees Celsius and then 60% relative humidity. So whenever we can see this, we can able to understand what types of process we need. So to convert 10 degrees Celsius to 25 degrees Celsius, we need a heating process. Okay? And then to convert 80% relative humidity to 60% relative humidity, we need a dehumidification process. Dehumidification process. Dehumidification process. Okay. So let's go into the topic. So this is the structure of winter air conditioning system. So same like summer air conditioning system, we have an air filter. So instead of cooling coil, we have the heating coil. Not a single heating coil, we have two heating coils. So first one is the first heating coil, the next one is the second heating coil. Then likewise summer system we have the humidifier, and then once again having the water eliminator, and then once again we will have the heating system. So let's getting deep into it. So first the air enters into the filter. It will be filtered, and then its temperature cannot be changed. Its temperature remains constant. Then it will move on to the coil, that is heating coil. So its temperature getting increases. Okay. Then also it will be came into the humidification process. So its temperature very slightly decreases, but its humidity will be getting increases. Why here we have to increase the humidity? Because we have to use a heating coil here. So whenever the temperature increases, its humidity value also slightly decreases in some cases. So that we have to use a humidifier. The next it will be moved to the water regulator. So in water regulator, large size water particles carried by the air are written by the water regulator. The next we will once again heat, that is the second heater. Then it will move on to the conditioned space. So this is the winter air conditioning system. So when we analyze these things, so some parts are common with the summer air conditioning system. So now I highlight the parts. Okay. So first thing is the filter. Filter same as the summer air conditioning system. The next one is the humidifier, and then water meter, and then that's it. Okay. So if you look at the summer regulation also, we have the same air filter, humidifier, and the water meter at the come. Okay, so this is the final complete diagram of the heater air conditioning systems. Thank you for watching. Thank you.